Hi, this is Alex Pault for Embedded Computing Design, and I'm here today with Dr. Kevin Speer of Littelfuse. And, actually, we're going to be talking about wide-bandgap semiconductors. Isn't that right?
That's right. Thank you, Alex.
Well, I'm really glad to have you here because, obviously, wide-bandgap goes into multiple flavors, but basically it's this huge wave. People are like, oh, gosh, what is this? I got to do something. I got to be involved.
Yep. Yeah, everything has really flipped on its head just in the last couple of years with Silicon Carbide. If you came to PCIM maybe 2 years ago, you would see a lot of booths have Silicon Carbide presence there, but it wasn't necessarily in a product form. Today, in 2017, there are many booths that have Silicon Carbide products in their stands, and we are happy to be part of that crowd.
Right. Well, we're here, and here's some Silicon Carbide. So why don't you tell us a little bit about what Littelfuse has been doing in that space?
Sure. So as of March 1st, we made a secondary investment in Monolith Semiconductor, and we're very excited about that. We're now a majority shareholder. So what we're announcing at PCIM this week is a couple of things. So first, we are in full commercial product scale with 1200 volt Silicon Carbide Schottsky diodes and 5 amp and 10 amp ratings. Throughout the rest of the year, we'll be developing some additional products at the 1200 volt class up to 40 amps. Also at this show, we're announcing that we're sampling 1200 volt 80 milliohm Silicon Carbide MOSFETs. Again, like the Silicon Carbide diodes, throughout the rest of this calendar year, we'll be releasing additional products with other specifications.
Very nice. Now, what kind of response have you been getting from your customer base?
Oh, people are very excited. One of the big commercial roadblocks to Silicon Carbide becoming commercially viable is that there haven't been enough trusted, credible suppliers. So with a name like Littelfuse that has a very strong brand, very trusted recognition around the world, having a Littelfuse name in the Silicon Carbide supply base is very exciting to customers, and they're hungry and they're very happy for it.
Well, and also considering your expertise on the passive side and on the packaging side, and that packaging is one of the big critical issues with wide bandgap. Have you been working in that space with new packages or different packaging or alternate packaging?
Yeah, you make a very good point, Alex. So one of the limiting factors for Silicon Carbide in a discrete package format is the parasitic inductance of the source pin. Like a TO247, for example, the source pin has about 7 nanohenries of stray inductance. This causes enormous problems. So what we're doing at Littelfuse is we're actually coming out with a 4-lead TO247 that has a Kelvin source that effectively decouples the power loop inductance from the gate source loop inductance, and it eliminates a lot of problems in that space. We're also coming out with surface mount packages that reduce some of the parasitic inductance just due to the pin length. Also, in the surface mount packages, we're coming out with the Kelvin source version of those. So we're very active in the advanced packaging space to enable customers to use this revolutionary technology in a revolutionary way.
Very nice, Kevin. Now, what about, of course, the rest of the board? And obviously, you make products for the rest of the board. What are some of the things you're doing to deal with the demands that Silicon Carbide place on the rest of the board?
Sure. So what we have as part of the partnership with Monoliths, we have a very heavily seasoned, deep bench of Silicon Carbide applications experts. So this is very different than having IGBT FAEs, for example, because it's one thing to design an IGBT application, it's something altogether different to design a Silicon Carbide application. So we have a deep bench of heavily seasoned Silicon Carbide applications experts that are ready and prepared to sit across the table with the design engineer, look at their schematic, roll up their sleeves, and help them with layout and other design considerations.
Well, and actually you take another step beyond what I had asked, which I'm glad that you did. I was going to ask you about direct technical support. So not only are you working on the infrastructure, but you're also ready to hand some of that expertise over to your clients.
Oh, absolutely. One of the points that I've been making over the last couple of days here at PCIM is, as a supplier of a revolutionary technology like Silicon Carbide, the burden really falls on the supplier to help the customers learn how to use it. So we are absolutely doing that. We have the expertise to do it, and we stand ready to do that.
Very nice. Now, because of the fact that wide bandgap is almost as much of an educational pitch as it is a product pitch, what kind of questions are you getting from your customers about it? Are they on top of it yet, or are they still grasping for answers?
Yeah, I mean, usually the first question is non-technical. It's usually about price. So when are we going to be at price parity with IGBT? So if we deal with that separately, one of the big questions that customers have is about gate drivers. That comes always because every switch needs to be turned on and off, right? So we also, as part of our application support, we have optimized driver solutions for our Silicon Carbide MOSFETs, and that's just another area in which we stand ready to assist our customers.
That's great. Now, is there anything else you wanted to leave our audience with before we ended this little chat?
Well, I think the big emphasis for silicon carbide, of course, is making silicon carbide mainstream. And the ways in which we're doing that are addressing a few different matters. We're addressing affordability through manufacturing silicon carbide using a fabless model, an automotive-grade silicon CMOS foundry on 150 millimeter diameter wafers. We're also addressing silicon carbide, making it mainstream in terms of availability. So Littelfuse, again, like I mentioned before, it's a trusted supplier with great supply chain security. And the last thing is reliability. That's another critical piece to making silicon carbide mainstream, because the silicon carbide MOSFET has had some problems over the years. We actually have data to support the statement that our silicon carbide MOSFETs last up to 100 years. Even up to high temperatures up to 300 degrees Celsius. So affordability, availability, and reliability, and that's what we're doing to make silicon carbide mainstream.
Excellent. Now, where can they go for more information?
Go to littelfuse.com.
Excellent. Now, Kevin, thank you so much, especially this busy show, for taking the time with us.
My pleasure.
And thank you all for taking the time to be with us too.